last objective of the unit, CO60. And it's kind of the ultimate quadratic equations objective because we're going, anything that we've done prior is fair game to use in CO60. It's word problems, it's parabola in context, it's you kind of have to pull from your toolbox what method to use. There's not one specific one. And so it does pose a little bit of a challenge, but we can handle it. Yes, sir. Question already. What? So CO60 today, this will probably be a 2-day objective. Next week, Monday or Tuesday. We shall see. You don't make decisions here.
Wednesday.
All right, here we go. Being the gentleman that I am, here's a brief review of the things you'll find helpful for CO60. When you come across a word problem, obviously the parabola may not always be given to you. So sketch it, right? Back in CO53, we talked about how to sketch. Looking at a minimum, a maximum, the Y-intercept. You just kind of got a rough estimate. Does it open up? Does it open down? Kind of to get an idea of what your parabola is supposed to look like. Okay, that will help you when you start to work with it a little bit. The Y-intercept, talked about that. How do you identify the Y-intercept given an equation of a parabola? Again, back to CO53 here, and PO54. How do you identify the Y-intercept of a parabola when you are given an equation? So you don't have a graph to look at, you have the equation, yeah?
Look for the C term.
Right, it's 0C, okay? 0C. And of course, you must know that parabolas are all in this form. Y equals ax squared plus bx plus c, right? That y-intercept is that c term, it's that constant, okay? Now, what does the y-intercept of a parabola represent? This is a little bit new, okay? We may have mentioned it briefly here or there, but what does it represent?
Parabola.
No.
The y-intercept.
Aiden.
The edge of the parabola.
Edge of the parabola, okay? Tell me a little more about that.
The vertex point is always to the side of the y-intercept.
Okay, so the vertex point will be in the middle of the parabola, so it's on either side of it. Damien?
Is it how many times it touches the x-axis?
No, that'll be the X-intercepts, and we use the discriminant for that. But for the y-intercept of a parabola, whenever you see the word initial or starting point, it's usually going to be talking about the y-intercept, the initial height, okay, or the initial distance or whatever. The word initial or starting point, that's usually going to clue you in that you're looking for the y-intercept, okay?
Can I see Rowan really quick?
Yes, Rowan, you're being summoned, okay? And the reason why that is because in context, with parabolas, you're usually only going to be working with that top right part of the coordinate plane. Because the top right part of the coordinate plane includes all the values that are positive. Okay? And so most parabolas that you have are going to be something like this.
So you're not saying that.
Okay?
I'm doing math up today, right? It's Thursday.
Correct. Thursday. Yeah. And so your x-axis, if it's asking you like the one we talked about yesterday, where it's the what was the height of the hose? What was the initial height of the water? If you're holding a hose and you're spraying water out, right? You're not going to care about this other part here, this other part of the parabola. You're holding the hose, it starts here, water shoots out like that, okay? So when you see the word initial starting point, be thinking the y-intercept there. Vertex, what is the formula for the vertex of a parabola? Back to PO54, formula for the vertex. Yeah, Joey. Negative b over 2a, that's your x value, and then you plug that in to find y. Right? Negative b over 2a gives you x, and then that gets plugged in to find y. And what does the vertex of a parabola represent? We talked about this one. It's got other names for it. Ellen?
It's like that minimum.
Minimum. There we go. Maximum. Highest point. Lowest point. Right? Things like that. Middle of a parabola. Yeah.
The axis of symmetry.
Axis of symmetry is part of that too. That's coming up next. Okay? But it's that middle point, the highest or the lowest. So when you're talking about parabolas and you're asked for a minimum, maximum, highest, lowest, you're thinking vertex. Okay? You're thinking vertex. All right. Axis of symmetry. How do you identify a parabola's axis of symmetry? How do you know where to put that? Imaginary line, imaginary vertical line. Max.
It's like cutting the parabola in half.
Cuts it in half. Okay. Tell me a little bit more, Elliot. Yes. Okay. It's the x value of the vertex. You've got a vertical line going through the vertex. Okay. So the equation is x equals, right, wherever it crosses through that vertex point. Yeah.
Could we use this whole page on it for a help sheet?
Are they all key points? And what's up the top? Ooh, my little avatar. That means I haven't decided yet. Depends on how I'm feeling. That's the day before the test. What?
Where's the little guy in
That's my little avatar.
That's
your avatar?
You?
Well, I
It looks
Google
like
image
me with
nerd and that's
glasses.
what popped up.
No, it's not.
Okay. In a parabola's axis of symmetry, it represents the middle of the parabola. Okay. Where you can fold it over itself, right? Axis of symmetry and vertex go hand in hand because the axis of symmetry is where the vertex is, right? Yes, Arlene.
Will a parabola always be?
Yes.
A parabola will always be symmetrical. Okay. X-intercepts. What are all the ways we've learned to find the x-intercept of a parabola? What are all the ways we learn to find the x-intercept? And more so than that, let's put the various forms. If you have y equals ax squared plus c, what's your method to find the x-intercepts of the parabola? Kylie. Opposite operations. Right? You're solving for x using opposite operations. What if you have y equals ax squared plus bx? What's your method there? Greatest common factor. Right? And I'll let you get that note down. Great thoughts keep flying in my head. What's the quirk? What's the helpful hint with this ax squared plus c method? What do you always know you're going to get? Ellen? Nope, not that's for the second one. But for the top one?
2 answers.
2 solutions, and there's one more piece to that. Liesel?
What are the solutions? How much do they do?
That's for the second one. Talk about the top one with an opposite operations. Because you end up rooting x, right? You always end up with the root of x squared equals something. So
You're going to get the same 2 numbers as one of the 2.
right, you'll get opposites. Okay? It's that plus minus sign. Okay? You'll get 2 answers, and they'll be opposites. For the second one, ax squared plus bx with that greatest common factor, that's the one where 1 will always be 0. Okay? And then we have that little shortcut of that opposite of your constant divided by the coefficient deal, right? To help us get that second one. Okay? Those tricks, those quirks, are all written as key points in PO 55. So I recommend you go back and throw them on a help sheet. The last one, y equals ax squared plus bx plus c, where you got everything. What's our method for solving for the x-intercepts there? Joyce. That's the one if you forget everything else and you only want to use one method every single time. But this form specifically, Ellen,
You have to
factor it. Okay? Factor it. That's where you're getting your 2 sets of parentheses. Right? We did that back in PO 51 and PO 52.
What adds to the plus
Right. Yep, that whole thing. And then as Joey said, if you don't remember any of this, and you're like, I just want one way to do it every single time, I'm consistent, I like it, that's where you've got the quadratic formula. This will work for all of them. It's what we covered in PO 59. Okay, the quadratic formula will work for all types. For all types.
So why is it a PO?
The quadratic formula
I mean,
or PO 55?
if you could do this, so for the quadratic formula,
Yeah.
you didn't want to do the quadratic formula, you just do the factoring.
Yes, but there are some equations that can't be factored. They work out to be a prime. So in those instances, you have to use the quadratic formula. Okay? But if it's something you can do mentally, because some of you are at the point where you can factor equations mentally, then why go through all the work of quadratic formula if you can do it there? Okay? And what do the x-intercepts of parabola represent? where it crosses the x-axis in context. Damien, what do you think?
How many times it crosses the x-axis?
That's what this the discriminant tells us. But like if we've got a parabola graphed here and it goes like this, and I'm starting it and stopping it on the x-axis, in contextually, what do you think that x-axis might represent? That we,
The starting and ending point?
starting and ending point. There was a question on your in CO60 about kicking a soccer ball. Where does a soccer ball start usually when you kick it? On the ground, right? Where does it usually land when you kick it? On the ground. So the x-intercepts, in that case, would represent where the ball starts, the path of your kick, and where the ball lands. Okay? So x-intercepts often represent the ground in context of a parabola. If you're asked when does something hit the ground, okay, that's usually thinking about x-intercepts. Yes?
Is it Y-intercept starting point?
So it depends on the context, right? We did say that for the Y-intercept, it's like initial or starting point. If you're talking about water from a hose, you don't start on the ground. You don't hold the hose on the ground like when you water, you hold it up, right? So in that case, it'd be the Y-intercept, okay? A soccer ball, though, being kicked from the ground, starting at that point, that'd be the X-intercept. So again, like I said, this objective requires a little bit of logical thinking here, which is why sketching the graph helps. Sketching the graph helps. Okay, let's tackle one. Let's talk about Michael and his watering. Michael points a garden hose upward such that the stream of water follows the path of y equals negative 16x squared plus 32x plus 5. So here's our equation, where x is the time in seconds and y is the height of the water in feet. So it's also important to know what our variables represent. X is the time the hose is running, and y is the height of the water as it goes. So let's sketch the graph representing the stream of water. And here's where, like I said, we're going to be working with that top right part of the parabola, because can you have a negative time? No. If you're watering your garden, you can't go back in time.
I mean,
Right?
Depends what kind of special solution.
Well, then you can all get this wrong on the test. Those of you that say, I have a time machine, so I'm going to do it. Right? I will gladly mark that.
Just click on doing the top left corner.
It's a CO, it's fine.
So we are working with that top right part of the coordinate plane. Okay? We'll say Michael is standing over here. Here's Michael. He's smiling. Oh, that's kind of. That's why I got a U and R. Yeah.
If you fail a PO on the or a CO on the test, is it like you have
It affect your grade. You don't have to read. So he's holding the hose, and the stream of water comes up and it comes down. Okay. There's our general sketch of what the graph is going to look like.
why wouldn't it start at the
I need you to raise your hand, okay? Damien.
Why wouldn't it start at the ground?
Well, because Michael, when you water a garden, have you ever watered a garden before? You hold the hose up a little bit, you spray it, right? Most people do. Maybe you're different. That's fine. Okay.
Different, but on general.
Also, look at the equation. How do we know that this is not starting on the ground? Raise your hand, please. Analyze the equation. How do we know that this is not starting on the ground? Damien, you want to listen to this? It's an answer to your question, right?
the C value is not 0.
Right. We can see the y-intercept here. We know it's not on the ground because of what the equation tells us. So right away, we can kind of label this point on the y-axis to be what? 5. Okay? And that leads very nicely into our first question here. What is the initial height of the stream of water?
5 feet.
And what did you do to find that?
We made a stick figure.
Right? Initial height. What is that word initial? I say kind of tends to y-intercept. Okay?
Is this gonna be like a question on the test, like not the exact same, but
Yeah. This
I
the
mean to
Well, no, this is kind of helping you what to think about. The question on the test will be, here's the situation, and then what's the height? How high will the stream be? What's the maximum height?
Stop.
Okay, so you need to then know, what does that mean I need
Oh, that's
to
not
do?
good.
Okay. All right, and then the answer to this is 5 feet. Okay, because the initial height, we know that from the Y-intercept, is 5. Kylie.
How do you know it's feet and not inches?
It does say in feet. Letter C. How high will the stream be after 2 seconds? I need you to stop just saying things, Ellen, and raise your hand. You're very interjecting today. Right? How high will the stream be after 2 seconds? How are we going to calculate that? Remembering that x is the time and y is the height of the water. Arlene, morning for you.
Plug in X.
What's that?
Plug in X into the equation.
Right. If the x represents the time and the y is going to be the height, if we're given a time, we're given a value for x. We're told to find the height after a time interval of 2 seconds. Because we're told that x is time and y is height, that x gets plugged into the equation, plug 2 in for x, and that's going to tell us the height of the water at that time. Okay? So our equation becomes y equals negative 16 times 2 squared plus 32 times 2 plus 5. If I asked for the height of the water after 8 seconds, what would you plug in for x? 8. If I asked for it after 12 seconds, you plug in 12. And how you know you're plugging it in for x is, again, back at the start, you're told what the x variable represents. X represents the time. So if you're given the time, you know you're being given the x variable, the x value. Lisa.
The answer is 5.
Oh, there you go.
Whoa.
Okay.
Whoa!
Yeah.
Do we have a second on that?
Yes.
Yes.
Yeah, I thought
What do
Okay.
you mean by
I haven't
that?
done it.
It has to have
Hold up, hold up. Raise your hand if you have a question. Raise your hand if you have a question. Jack?
Does that mean you agree with someone, or you just don't?
That means you agree.
If you second someone's opinion or someone's answer, you agree with them.
Alright.
3 times.
Let me,
Yeah.
did anybody else get 5?
Yeah.
Okay.
That helps.
Okay. So,
Yes, it's super hard.
folks, Damien, turn around, please. Damien, turn around, please. Why does that make sense? How can we have both a y-intercept of 5 and the water being 5, a height of 5 after 2 seconds? Elliot?
Is this like the opposite side?
Well, no, that would be -5, which doesn't make sense because that would be going back in time, right? Burgess?
It's a strong hose.
Tell me more about that. What was that?
Water gone straight.
Oh, going straight across?
Yeah, you put it on.
Gravity might have something to say about that eventually.
It's the other parts of the parabola where it's equal with 5.
Right. What goes up must come down. So as we solve for these things, we can kind of add to our sketch here. If the height of the water is 5 feet after 2 seconds, that means that this point, horizontal from our y-intercept, Elliot, your phrasing of the word opposite, right, would mean -5, which is why it doesn't quite fit like here. Don't use the word opposite unless you're talking about the opposite side. In math, opposite means, well, it's not the opposite side. I mean, it's going forward, right? Okay. You just say where the water starts to come down. Okay. It's coming down at 2 seconds and it's at that same height as the initial height. Okay. Questions on that? Elliot.
So now would we like, to get the highest point, would we like put it through the middle and that would be 1?
So letter D now says, what is the maximum height of the stream? What is that asking you to find? The vertex. Okay? And more so than that, which value of the vertex?
The first one.
The y value. Okay?
Well,
Damon, do you want to stay in the class or just want to go in the hallway? If you're so interested in looking at what's behind you, you can peer through the door and see everything from out there. They're not bothering anybody.
He's winking at Vince.
Okay?
What?
Jack, what the heck?
Jack. Okay, if you want to leave, then just go. I'd much rather you just be out in the hallway than having to stop class constantly. Okay? So we're looking for the y value of the vertex here. We know that because it's asking for that maximum height. Height being the variable for y, or the value for y, that's the part of the vertex that we are finding. Okay? So, couple different ways here that we can calculate the x value. Because of course, in order to find y, we have to first know x. Give me two ways that we can calculate the x value of this vertex. Max.
One way is to get from both sides to the thing, it's 2, you just like split it in half.
So one thing is, remember, parabolas are symmetrical. Meaning that if our initial height is at 5, and after 2 seconds, it's also at 5, what's happening at 1 second? It's the middle, right? You need to stop saying things, just shouting them out. Okay? That goes for everybody. Was that you again? Okay, just, right? We cannot just be shouting things out. At 1 second, we're talking about the axis of the symmetry here. Okay? That's that middle of the parabola. So that's one way. Look at the sketch. Again, why the sketch is helpful. What's the second way?
Negative b over 2a.
You can calculate it. Negative b over 2a, get the x value, you're going to get 1 as an answer to that. Right? So now that we know the x value is 1, because we want the height, what are we going to do with that 1? Elliot? Plug it into the equation. So y equals negative 16 times 1 squared plus 32 times 1 plus 5. Oh, I put this positive 16. Negative 16. That'd be helpful. Okay. And what do we get? Sophie? 21. Okay. So the maximum height of the stream is 21 feet. Because that's the value for y when x equals 1. And we want x to be 1 because that represents that vertex, that middle of the parabola. Damien?
How do we know the middle is 1?
2 ways. First of all, you can calculate it by using negative b over 2a. Or because these two values, the heights are the same, and it took 2 seconds for this hose to come up, the water to come up and come back down the same height, 1's in the middle of that.
You could have also done negative b over 2a.
You could also done negative b over 2a. Arlene, you're looking at me like I'm saying something wrong.
No, I went beyond. I went ahead.
Oh, so like the next part?
Yeah.
Perfect. Okay. Any questions on what we have here so far? I have to erase the sketch to scroll on. Actually, you know what? Let's not. Let's keep the sketch. We'll stick it right there. We'll kind of there. Oh, there we go. That's what we got. And then we will erase this. So we kind of got that sketch there still. Okay. We'll go right there. All right. Ooh. How long will it take the stream to reach the maximum height? What is that value?
1 second.
And how do you know it's 1 second? Damien.
It's half of the 5 of 5.
Right. This here, Ellen, second warning for you. If you want to leave, go. Your first time where I had to single you out and talk to you about blurting out, that was your first warning. It wasn't vocalized, but that counts. Okay? Rein it in. All right. How long will it take the stream to reach that maximum height? Damien said 1 second. Okay? And we know that because, first of all, maximum height, there's our vertex. That's that key phrase, that vertex point. And then the question, how long will it take? That's talking about time. Right? X being the value for time, we want the x value of the vertex. X value of the vertex, which we calculated to be 1. We already got that based on the axis of symmetry and by plugging in negative b over 2a. Yes?
Wouldn't that more technically be the axis of symmetry
It's the same thing though, right? The x value of the vertex is the axis of symmetry, so it's one and the same. Okay. Letter F. How many seconds until the stream of water hits the ground? So here we're looking for this point here, right? Where the stream of water hits the ground. Arlene, do you want to take this one?
You have to solve the equation.
Okay. So remember I said that word ground kind of represents the X-intercepts here. And if you see the sketch, we see where it hits the ground. That's the X-axis. We need to solve for the X-intercepts. Okay? And based on the equation that we have here, which was negative 16x squared plus 32x plus 5, I'm not too hopeful of a factorable of the equation. And so we're going to go ahead and use the quadratic formula for this. Okay? Because we only have 2 minutes left, if there's someone who's already done the quadratic formula and has the answers, I will take them. Who has done it and has solutions for the X-intercepts? Anybody?
Alright.
Only this is your time. She did get it.
You can also practice.
Oh.
You're the one who's going to do it on your test. So you can practice it now as well.
You're gonna do it. Oh, yeah.
If you're not working through the quadratic formula right now, you are not doing what you need to do to prepare for the upcoming test. I'd be nervous, unless that's a discriminant people's found. Anybody? Arlene?
I mean, I don't have the answer yet, but I got negative 32 plus or minus 36.66.
Okay. So negative 32 plus or minus 36.66?
Yes. I got the answers.
Okay, Aiden, what you got?
Negative 0.15 and 2.15.
Okay. So you do the quadratic formula and you get negative 0.15 and 2.15. Obviously, the stream of water can't hit the ground in two places, right? So again, thinking of context here and looking at the sketch of this graph, which one are we going to go with as our answer? Positive 2.15. The graph of this parabola does hit the x-axis at negative 0.15, but we don't have that part of the graph because this is in context here, right? A stream of water is coming out of a hose. Okay? No homework. We'll go through this again tomorrow. Have a nice day.